In order to tackle part A, to find a value of b such that the limit exists at x approaches -3, we have to check both sides, the left and the right. And so the left is defined by x squared minus 9 over x plus 3, and the right is defined by x plus b. We actually don't care what happens at a for just the limit, because we're looking at the left and right side. So as I look at this, the right is easy. I just plug in -3 for x, and I get -3 plus b. The left is harder because when I plug -3 in, I get 0 over 0, and that's indeterminate. So instead, I can look to use L'Hopital's rule, which says I'm going to take the derivative, 2x, and the denominator is just 1. And when I plug that -3 in now, I get -6 equals -3 plus b. When I add 3 to both sides, I can see that b must be equal to -3. So that's the answer. Yes, there is a b. b equals -3, because I set my left and right limits equal to each other. Now as we look at part B, we want continuity. So that means we need to satisfy these three things. The limit exists, the function exists, and the limit equals the function. Well, because of part A, we know the limit exists when b equals -3, and the limit that we found was -6 equaling -6. So when b equals -3, my limit equals -6. Well, my function will exist at whatever this a value is, because that's when x equals -3. I'm not sure how that got deleted. So that means we want the limit to equal the function, and that's only going to happen when a equals the function also equals -6. So part B, the answer is if a equals -6 and b equals -3, then we'll be continuous. Now we need to look at part C. Part C requires differentiability. For something to be differentiable, we need two things. One, continuity, and two, slopes must match from each side. Well, we already proved continuity in part B, so now we're really just checking the slopes. And to find the slopes, we have to take the derivative on each side. And so we're really taking the derivative of x plus b, because that's the right side, well, the derivative with respect to x of x plus b equals 1. So now we have to take a look at the derivative on the left side, which is x squared minus 9 over x plus 3. And if you take the derivative of this, you're going to have to use the quotient rule, and it's going to be pretty ugly, but ultimately you're going to get 0 over 0. You're going to get something indeterminate, which isn't going to help you. But instead, if we thought about factoring this, this factors into x minus 3, x plus 3, all over x plus 3. This x plus 3 cancels out, meaning we really just have x minus 3 and we have a removable discontinuity, remembering way back, or a hole, and we filled in that removable discontinuity with a was equal to -6. When I plug -3 in here, I also get -6. And that makes sense because we found that we were continuous. So really, we're just looking at what is the derivative with respect to x of x minus 3. That's what's left after we factor out our whole. Well, the derivative of this is 1. So was the derivative of this, because when I plugged in that b equals -3, this was also x minus 3. These are the same thing. This is just a line, so of course it's differentiable, because on both sides the derivative equaled 1. Just a review of everything required for differentiability.